RIP, so which is implemented on top of your distance vector routing algorithm. Okay, so what we studied distance vector routing, which uses the Bellman-Ford algorithm to find the shortest path or something. Okay, so the practically implemented of our RIP, and we'll try to understand how you can able to enable those routing protocols on top of the router. Okay, so and which scenario we should use that protocol. Okay, when we should not use that protocol, we will discuss all such things for today's class. So because when you are studying the theory part, we would understand RIP is only meant for small networks, it will not be meant for a big network, right? So we have something instability in this protocol because since so the routing information would be updating based on the whatever the neighbor router is going to send. Okay, so the probably there might be some instability may arise. Okay, so due to avoid that instability, we would be having some temporary solutions like what we discussed, something called poison rivers or whatever we already discussed. Okay, uh, so even though if you're having all temporary, which not makes your network more stable. So based on that, your RIP is only mainly meant for a small network. Okay, so the Cisco would recommend like if you have some amount of number of devices routers, so we could use this RIP. So if the network goes beyond that limit, probably we should use a different routing protocol. Okay. So all these terms would comes when you are designing, when you are planning your network. Okay. So which protocol I should use, whether I should use an RIP or I should use an OSPF, I should use an EIGRP, and what is the device I'm choosing for this network. Okay. Whether you go for Aruba or if you go for HP or if you go for some other vendor products like Juniper or some other devices like hmm, Cisco or any other device as such like Brocade, so and so. Okay. So you have to think on it, which device I should use. Okay. After that, you should think which protocol I should configure. Okay. So what I will going to do in this class, I will try to cover all such things, and I would also like to give some the real time so yesterday I've been visited to our own college like what we have in CS building. So there will be a new construction on top floor, right? So yesterday, me and Tagraj Murthy sir, we visited and we have decided to plan a network design for the new construction building. So they asked which would be the better, either wired or wireless. So whatever upcoming the labs like innovation labs, our e-learning center, everything which comes in the CS building, which is constructing newly today. Like still is not completed. Once it's completed, probably so you would be able to use all those facilities. Okay. So we've been like there like to design the network for that. So what is the requirement? So they give the layout diagram. So then they will say the requirements like so whether that room is going to be a classroom or anything something other than that, whether it's going to be a lab or so and so. Okay. So once you are able to understand the requirement, then you should think your network planning so and so. Okay. So thinking of planning, designing a network is not a difficult thing because like whatever the user or customer says, these are the requirement. Like I need a fixed this many number of ports and I must have a coverage, the wireless coverage around like this region and so and so. Okay. So providing this fixed points is something almost uh, where you can think and you can itself by seeing the physical location itself you would be able to understand where we should put the rack or what you call the switch and how the cable has been taken from there to each wherever the customer they would like to need that fixed point so and so. That is not a big deal. Okay, so whatever that we are planning over there in the new construction building. Okay, So it's just an extension what presently we have an existing network. So we are not going to design any new network, or we are not planning anything different than what we have in existing. It's something like it's just an extension, uh, an extension. But the thing is, the wired network will be minimum, and the wireless we are concentrating more on it. So once you concentrate more on wireless, so we must to decide where we should place an access point. The very first point will comes. So in which location that you need a coverage and where we should place it. Okay. So when you placing that access point, and you should also think the surrounding of that where you going to place that access point. Is there any kind of radiations, or is that brick walls, or is there is some any other different kinds of walls that you have? So where it makes reflection so and so. Okay. So in order to design, so earlier days we used to use some kind of an instrument or some kind of an app. So if you walk around through that location where it will able to gives the coverage area, if you place at any point of at any point, if you place in an access point, it will give the coverage area. So similarly, we would be having such kind of tools where if you upload your layout diagram, so and if you design wherever you have a closed wall and which kind of that wall it is. So based on by giving this input itself, that software would able to understand. So what kind of an attenuation can come across in that location or something. Okay. So so just what I will do, I'll after explaining this after completing this portion, I decided to complete today. So I would like to show some on one of the a tool which is provided free, where you could also design and wireless network, a kind of identifying the place where you keep your access point, you would be able to get the coverage. Means you still connected. Okay, means you would able to get the signals over there. Okay, so probably you might have faced this kind of conditions where like you buy a connection from a service provider, and you need an wireless access, so that you will also buy an wireless router and you connect it. But in your house itself, if you go somewhere, you are not able to get, or you could not able to get the signals over there, right? So probably the placement of that access point may be a problem, or it would be some an obstacle which is avoiding your signal which is transmitted. Okay. To avoid all such things, you have to have something. Means you should be visualize like what is the physical location, which would how it would be, or having this layer diagram, and knowing that where and where that walls and everything would comes. By designing it, you would able to understand. So so where you can place your access point to get so the complete coverage to our building. Okay. Not only that, it along with that, it is also depends on the hardware specification. Means which device access point you are going to choose. Okay. So if you choose a lower end device, it will not gives a higher range coverage. Okay, high range coverage. Okay. So probably the choosing of that access point would also be a uh, kind of thing you should keep in mind when you are go for any kind of network planning. Okay. So so what we will do, the previous one, what we had an experiment, which we understood the DHCP, and also we understood the HTTP process, like how this connection would established between a client and a server, and for every request, so there is a TCP connection. Okay, once the response comes, the TCP will be ended, something like that. So we were thinking out for the existing infrastructure, what we have currently in my on the screen. So we would like to give some wireless access for that. Okay. So it's just an extension. Wireless technology is not a predominant or individual technology. We would say in somewhere, in some point, we would be having the complete wireless, but whatever you've been seeing in any organization somewhere, so it's almost a kind of hybrid. Okay, that complete in like organization will not be having a complete wired or wireless. So it's going to be a mixture of both of them. Okay, so you'll be having wired as well as wireless, and you guys have known that what is the advantages of wired and wireless. So wired, where you say it's a fixed point and the bandwidth is constant. Okay, so there will no be fluctuation with your bandwidth. Okay, uh, and it's more secure than the wireless. Okay, no one like they will not able to theft the data in a wired network, but wireless we can able to do all such because it's spreaded across the free space. So if they have anyone connected, they would able to penetrate something for an infrastructure to gain an access to it. But in wireless, we would be having some a level one security means if someone wants to gain an access to the network, at least he must have access to the physical network. Okay, somewhere he must connect their laptops to the point where we have provided. But this wireless is not been like that. If you have a wireless adapter or something which is connected to your PC, if they are connected, if they are able to receive the signals, they can easily penetrate and able to gain an access to the network. But in wired is not in such. Do you know what is the wireless security or the encryption algorithm we would be using? Can anyone tell?
WPA2, sir, currently.
Uh-huh. Yes, Joyce.
I think it's a WPA2 right now,
Okay.
currently being used.
So WPA2. So do you know what is the abbreviate like acronyms for WPA?
Wireless protocol access, I'm not sure, sir.
Okay. Have you heard about WEP?
That is the first version, right, sir?
Yes, yes, yes. So the earlier days we used to use WEP, and now we have been using WPA2. So it's an advanced version of that WPA1. Okay, probably this you would be going to cover or we want to learn in your mobile communication in the last unit. So there you're going to completely discuss the wireless technologies and the security. Okay, so there you're going to study this complete the algorithms and how this protocol is being working. Okay, so you just keep in mind that we need a more security for wireless than the wired. Okay, so because that wireless network is easily accessible. Okay, if you have your wireless network in your home, even the next neighbor, the person would also able to get the signals, right? Okay, there is no the security. It's something like it's spreaded over here, and they would able to access it. And if you know the password, if they know the password, they can easily enter into your network, and they can do whatever they want to do. Okay, something is wired is more secured, and wireless is something exposed to the vulnerabilities. Okay, but we need a wireless. Why we need a wireless? Because it has its own advantage. Okay, so even the devices which is not fixed means if you want to move from one point to another point and you've been still want to be connected, probably the one prominent technology we've been using is wireless only. So we cannot use their wired because that is static. So we cannot remove the cable and again shift that cable to where you'd like to sit and access the network. So if you look at this, so both have some advantage as well as the disadvantages. So if you're go when you're planning for any kind of network, like I would prefer like to have an hybrid. Okay, some amount of wired and the wireless would be better all the time. I think you catch my point why I'm saying why I would be recommending the hybrid. Okay, so wherever we would be having the labs or something kind of a setup which is fixed, you could go there. You could go for wired, and wherever you're not a fixed kind of infrastructure, then you can plan for wireless. Okay. So if you look at the wireless, now it is been operating in two separate bands. One is 2.4 and 5 gigahertz. So designing that could also be one of the challenging. Okay. So wireless, when you decide where you want to place that access point, probably there might be some kind of interference. Means the signal which is emitted by one access point, probably that get overlapped with the neighbor access point signals. So you should decide a proper point where you should keep the access point where you will able to get very low interference. Okay. So all those things you would able to design, and you would also able to visualize after once you're getting into the deployment stage or implementation stage, network implementation. So what exactly, how exactly your network will be deployed, and also you would able to get the whatever the desired performance that you looked earlier prior when you are planning that network. So if you simply go with blind and you are designing something in network will not given the better performance. Okay. And also you should not go without having some idea to design wherever you need something an access or something like that. So with an optimal level should design in such a way that your network should give very high performance and efficient, and also it must have something called fault tolerance. Even that access point fails, the chance is less, but in some case if it fails, so there must be, you must be planned within redundancy. Okay. So keeping all this mind, okay, you should carefully think when you are planning something, a network design for kind of an any kind of an organization. So today what I will do, I'll just give a small, a very small, so like how you could extend a wireless connectivity to your existing network. So that's why I've been using the previous one network itself. I'm not going to change anything. So I just take an access point, I've just connected that to an existing network. So once that connected, so the portion of that coverage, the region, so if any of devices you place, that devices would be able to get and connect, they would be able to connect it to a network. Okay, you got my point. So later classes, so we'll going to plan like how an organization such like our SJC or something, how they've designed this and wireless network to the existing wired network. Okay, I just give, I'm not going to create the prototype of our JC network. I just giving an idea where you would able to extend, how they would extending this you are existing with an wireless network also. uh, and the later classes we will see how a network which is deployed in our SAC. I'll show you that the related document, and as well as I'll try to give an example on that. Okay. So if you look at our example, our JC network, we would be having around 200 and around 2 to 250 number of APs in different locations. Okay. And all these APs are connected to one centralized managed device we call it as wireless controller. And we all know that something like we studied like right in 802.11, something a basic service, this the building blocks of your wireless network is going to be having the BSS connected, right? BSS basic service set and ESS extended service set. Okay, so we'll try to put from the basic service set understanding it. Okay, what is basic service set is basic building blocks of your wireless network having one access point at the center. Okay, and to that coverage area, that so the mobile devices are belongs to it. Okay, that is what we would say is one building block or one small wireless network. We must be have an access point, so where that access point is able to provide the connectivity. Okay, connectivity means it able to get the data from your end device and transfer that to a network on a public network, and the vice versa it will does. If you don't have this access point, then probably we would be saying an ad hoc network. If you don't have an access point or centralized node, so we say that kind of network as while ad hoc network. There is no one managed something a device where we call it as. Okay. So, giving an example to this is like when you have like a network connection to your home. So the point where it comes to your modem is still a wired. You will probably will be get through with a coaxial or a UTP or even a fiber. Okay, but thereafter from the modem, when you connect it to a wireless device or router, whatever you call, probably that from that onwards, we would be saying it's a one basic service set. Okay, it's a centralized access point. To it, your devices are get connected. From there, it will going to forward to your modem, and modem it is go through fiber, then it is connected to backbone network. Okay, the one simple example I would like to give here is just like I would like to select the wireless device which would be available here. You can see here, you can select the laptops. Like laptops are now comes with um, Wi-Fi, right? I'll just going to select the end devices as a laptop. Even you can select this wireless tablets or anything, whatever the devices or end devices are available in this software. Okay, even you can select the smartphone, so and so forth. Okay, to this we said we need an access point, right? If you keep moving to this wireless devices, you able to see my screen? Yes or no? Yes.
Can see, sir.
Okay. So if I click on this wireless device, okay. So here you would be able to see the n number of devices which enabled with this wireless capability. Okay. So in all such, I going to select this access point. Okay. So just click on this and you just click on here. So just that will be get appeared in your workplace. Okay. So what I must do here in order to extend this network, because I would not able to provide a fixed point over here, because I would say this would be not a building or something. It's an outdoor area, but still that point, the region, they would need an access to network. Understanding what I'm saying? Understanding? Probably you would be think like next to the DSP lab, we'll be having a main road, right? And road and next to that park, but there will be no network connectivity. But still, I want network connection. I cannot give a fixed point there, right? Because it doesn't have an infrastructure or any kind of building something. So the only possibility you should draw a cable and give an point or the each tree. That really awkward and it not looks nice, right? So where the technology we could use there is wireless. If you place an access point in any of the edges of the building, so that would probably gives this coverage region. And you know that if you place any access point, it gives a complete circle. It's the coverage area is complete circular. The coverage area of the access point is circular. Okay. The complete practically you can look at if you have any of these access point. From that point, you will be having with a radius of 2 to 5 meters. So the complete circle you would be able to get the signal. Okay. So what I will be doing here, just connect this access point to the existing network only, and just click on this access point and just go to configure and port 1, and I will just enable this port status, and I'll give the SSID. SSID is something I'm giving a name to that wireless network. Okay, keep that in mind. SSID is something I'm setting an ID for this wireless network. Okay, so when you turn on your Wi-Fi, you would able to see some network address, right? So SACE, so, right? So that is what actually an SSID. Okay, if you have multiple access point, probably if that belongs to one wireless network, probably all the device must have a same SSID. If that differed with any SSID with any different name, probably you will not into one same network. Keep that in mind. Okay. So then, so authentication, if it's so, and if you need, you can click on it and you just give whatever the IP, like password you would like to give. And the type of encryption is 64-bit. Okay, type of 64-bit encryption, 64-bit encryption. So this is actually a older type of encryption method. Now whatever we're doing with is 128 or 256-bit encryption. Okay, so okay, you just understand that part. Then you click on this, so and you know that the port status is on, and the bandwidth and the duplex, like the way of communication is duplex. Okay, and we all know that in wireless is almost half duplex. Okay, and the bandwidth is 100 Mbps. Okay, and the display name should also, you should write the same SSID name. Just click on it and you go to attributes. Attributes, you will get some more information on this device, and physically how this would looks, it would looks like this. This is a the back end view. Okay, and this is MTBF is something, mean time between failure is 30,000 something, cost is something, power source rack unit, how many units they will consume in a rack is 2 units, and the wattage, so and so forth. Okay, so this is just a simple configuration of the access point. So then what you must do here, I have to click on this uh, computer, and I have to remove this wired adapter with wireless, which is WPC 300N. Connect it and then turn on. Okay, go to desktop, click on this wireless PC wireless thing, and click on connect and just refresh. Okay, once you click on that refresh, it's just like the device is discovering is there any wireless network is available. So then you can see here the wireless network name SSID is SJCE and the channel is 1 and the signal strength is 75%. And also you will get some more information like what is the mixed type, network type, the radio band, security, and the MAC address. Okay, just click on this, then give connect, and it is the security is used web 64-bit, and key give the key in whatever the key security key you have chosen, then give the connection. This is get connected. Okay, close this. Once it's connected, the point here is we are not enabled or we are not comes to this part so far, like we are not discussed at all, right? So since we'll go with the manual way, one dot something, I'll give 7 or something like that, then I'll just give the default gateway. And what is the DNS address? 172.168.0.4. So I'll just go with as it is, like this is a DNS server, and I just configure that over here. Okay, and the same thing I would be doing on the another, which one I selected. I will just remove this wired one and I'll connect it this wireless module and turn on. Okay, and then connect it, go to desktop, wireless connection, then refresh. It will discover is there any wireless network is available. You will see SJCE connect, give the connection, then give the password thing, connect, you remove it, give the IP address static, which is 192.168.1.8. Then 192. The gateway address is the router address. Then the DNS address. Then click close. You finish that. Okay. And if I click on this and if I go to this browser and if I give how we did the previous one, just like that only if you do it, you would be able to get the web page. Probably this would take some time because so instead giving it, what I will do, I'll just click on this packet, creating a new PDU, and I'll create on this. So the status is fail. If I do one more time, probably, so that would be successful. Okay, and you just delete and go back and click on the same browser and give that same domain name. You would see able to see the web page. The same thing, I just click on this click on this web page and I'll go to simulation mode, and I'll just give the another server which is connected in the service provider, and you just go with this trace. So the DNS query, TCP connection, then HTTP should send, and HTTP request has been sent and responses comes. And if you look at now, probably another 2, you would able to get that web page on your laptop or your hand terminal. So what is the thing we understood here? So we would be extending your network with a wireless. It's very simple, nothing complex here. So we were understanding how this could be enabling your existing fixed network, where you would also extending your coverage region. So if you look at the previous time, so the technology is like wherever you go, you still connected. Okay. So if you see the 10 years back or something, the technology is going to be like evolving to make all of them are connected, are giving wherever you go, you will able to connect. You means you still get the connectivity. But now, so present what we are in, it's not a connectivity. We are make everyone to get connected, making everyone to get connected. Okay, not only humans, you make every missions and whatever is existing now, I think you are making them everyone to connect to an internet. Okay, so this is one simple thing. You just do it by your own, and you can do with another network or something, or you could do it with the same what you did in the previous one. So not this simple, it is not even one experiment. It's just giving an understanding how this wireless would be integrated with your wired network. Okay, so this very simple one, this is not exactly we done in our campus. So we would be having a plenty of this access point where all these access point are connected to one controller. So is the centralized point which able to control all this access point, and that wireless controller is connected to the our wired network. Understood. So probably with and separate network diagram. I tried that, but I would not able to get the diagram. Once I get that diagram or something, I'll just show you that. So and you would also able to understand how this design or all what are all the things they would think before they're going to design this kind of networks. Okay. And just to a point, I would like to give here something yesterday which I visited. Uh, it will not be opening with this. I'll open with some other tool. Next one, like if you go scroll down this page, you will able to see somewhere here the net wireless Wi-Fi designer and Wi-Fi inspector. Click on this software. So this something a web-based application as well as the standalone application. Okay, you can just log in and you upload your diagram and you can able to see the design. Okay, or you can download and also you can do it in your local machine. Okay, just what I will do, I'll just click on this login and it will ask some basic information. If you have login, you can just click click on this. Probably I think you will not be having this username and a password. Just go and register with this. There is nothing, just free. Then click on login and just click on login. And I already yesterday I uploaded this actually for designing for our college itself. And you just look at uh, uh, the placing of this access point. Okay, you can zoom and zoom out. Okay, here you will have a facility like you can measure what is the distance from this point to this point. Okay, the scale, it's something like it's not probably it's not in meter. If you divide that with an 100, probably it will gives 10 meters or something. Okay, this is actually 34 cross 30. Okay, you can change the scale either from a meter or it from a feet. Okay, so and the next one is you will have a facility like to define where well you will get the walls. So obviously you can this seeing this diagram itself, this actually is a complete wall. Okay, this is the space where comes enters and entering and out, and this is the space you could see here. This is all windows. Okay, ಗೊತ್ತಾಗ್ತಿದ್ಯಾ? The double thick line which you see here, it is a closed wall, and where you will see this single one is something a window it comes, and this is the entrance or open. I'm talking about in specific e-learning center. Okay, and I'll just click on this. It's something it says like when I click, when I placed my icon over there, it show the draw the continuous wall or something. So what I can do here, I'll just draw the continuous wall. So here, and I'll just click right click, and again I'll draw from here to here. Okay, so I'll just define this is the closed wall, and where I can place the access point here. I'll remove this mode, and I'll go click on this access point. Then it will ask you to select the access point model. There are wide varieties of model. So in order to know about each of this model, you should be see the specification description or something. And here in the right hand side, you would able to see something 3 cross 3, 4 cross 4, 2 cross 2. Something you know about this, right? What all these are? 2 cross 2, 2 cross 2, 3 cross 3, or something 4 cross 4 is it gives the number of antenna, right? 2 cross 2 means 4 antennas. So we use 2 for transmission and 2 for reception. Isn't it? MIMO technology. You studied that in your CCN class, right? Yes or no? Yes. Okay. So you select whichever is the access point you would like to. So then click OK, and you just click on this where you would like to place. So you can drag and you can place this. Okay. You click and you can see this. This is what you got the radio, but the radio frequency button. Okay, 2.4 gigahertz, and you can place from where, like this is 5 gigahertz region and this is 2.4 gigahertz region. So you can select this range. Okay, then if you zoom out this, so you could see here okay, I'll just enable 2.4 and the transmitting power is 20 and click OK, and I'll click another one and I'll place this over here. So this probably this region, whatever you see the green color, so you can see the scale over here in the left bottom. Okay. So if this is this would tells the attenuation. Okay. So probably 75 dBm is where you would get in this location, and this will be the less in the in this location. If you zoom and see, you would be able to distinguish these different colors. Okay, so this is red, orange, then it goes light yellow, then it upon it this will completely green. So probably why it is not clearing this, like cleared with this coloring, because I have not selected a proper model. Okay, so if I select this model and if I place like this, so it's something this makes to Iceland. So we'll be able to get only at this region. Okay, and only at this region. Probably whoever who visit this point or something, they would not able to coverage. They get the signals over there. So for that, and see what is the type of environment, is something dry ball I have selected. So something, a brick wall, window, door, elevator shaft, or any other bookshelves, cubicles or something. You have to select appropriate the building type. Okay. So I'll just click on this dry wall or something or brick wall. You would be able to see a respect. The design will take this type of attenuation. Okay, so the thing, mainly thing here, first you should keep that in mind, which uh, the access point you should be chosen. Okay, so probably at the end, so I'll give the complete the design of this network. I'll just give an overview on this wireless actually today. So probably you will, in this point, in this picture, you would able to see how this network. So there's this complete layout is only comes with 6 access point, which almost cover the complete region. Okay, is it clear or any doubt so far? So not only doing on this, we would also plan something called redundancy. So what you mean by redundancy? If one of the access point fails, okay, most of the time 90% access point will not fail. The only the some soft configuration, whatever we do on this network devices, probably that may get changed. Okay, due to that you are not able to get access to the network. Okay, if something the hardware in that API is failed, so you should plan in such a way that the redundant network or some other access point which is next to it should take off with this network load. Okay, or putting a two access point next to it itself. One should work on 5 gigahertz, and another should be working on 2.4 gigahertz would also can be done. Okay, so the next one, so just do this one and just go exploring this. And the next one is one task given to you, the similar kind of task which I given in the last class, which is FLSM, right? Subnetting. Today I'm going to giving the VLSM part. So VLSM, we all know that variable subnet, variable and subnet masking. So the requirement of number of hosts or the valid IP addresses in the each LAN network or networks will not going to be same. Instead, it's going to be vary. Okay, something you need here 16/16 here 27 30 30 30 30. Here it is 27. The number of hosts is required is 30. So the host needed is 2 2. So then how you going to design this? Okay, this complete network is the address is 192.168.1.0/24. Okay, but designing this to respect to each separate independent network is the job of VLSM part. So I'll upload this. Along with that, I will going to upload. I will going to give the instruction like what is the network address given. Based taking that network address, you should design in such a way that I given even the subnet range as well. You can in the diagram itself you would see this the range. Okay, at least you should write the range from where it would start from 48. What is the ending portion? At least you must write it properly. Understood? Understood or not? Yes or no? Can everyone do this one right? VLSM. There is no much things here. So once you design this network, okay, and you know what is the range, network range, what is the valid IP address, then you should create the same network over the Cisco packet tracer as an IP address to each this interface with that valid host network range. Then you configure it through wireless, wired or something. So wherever you see this black and vertical and horizontal line, this is something called represent LAN. So I'll be having one LAN here, one LAN here, and another one LAN here. So for that, you're going to just add one PC for each one of them and assign that PC with this valid IP address, which that you decided for that network, the range, whatever the range you decide. Okay. You decide and assign and create, configure, and you all know that this CLI commands, right? Whatever you discussed in the last class, CLI command, what is user mode, privilege mode, so on and so forth. You use that and do it, configure it, and come with your like the completion of your task. Okay, so we'll go to the next one. The quick, I'll just give a quick introduction. Okay, so I'm not going to do that in this simulator. Instead, I'll just go through with this document itself. You just also cross verify. If you have any doubts, you can come to in the next lab. Okay, so in this is lab 3. Okay, I'll upload the same in the Google Classroom, and you will find the question as well as the what is the task as well as the answer. Okay, what you're supposed to do here. So everything is given here itself, and what is the command you should also use, everything is given also. Okay, so there are 3 scenarios here. Okay, you should also do the same thing. So have one LAN network here and another network and another network, and 3 of them are connected or something. You can think of it. This would be your uh, head office, and these 2 are sub branch offices. Okay, all these were connected. Means this is one complete local area network. So this would be in Bangalore, this would be in Chennai, and this would be in Hyderabad. Okay, for internally you would be configure in such a way that it's not going to be used in the public network or the way connected. How these 2 are connected? You from this point you connected to the local ISP, and this point they connected to local ISP, and ISP they will provide the connectivity between these 2. R2 and R3, something like that you can think of. Okay, clear? So for this network, what I am doing, I'm not going to use a static route, but instead I'm going to using the RIP. So where that protocol which helps to discover the remote network without any network administrator involvement. Okay, dynamically it will discover the network, remote network, and I'll update that entries, update that information in its database. Okay, means this router should know about this and this, because it is 3 network and this is 5 network, and also you should know about 4 network or router R1. For R2, it should know about this 1 dot network and 5 dot network, because these 2 are remote networks to this router, because this is local. And for this, it should know about this network, and this network, 3 network. For these 2, it should discover the 3 remote network, and for this, it should discover these 2 remote networks. Okay, when it comes to this configuration, it's very as simple. Okay, you are enabling this RIP protocol on the each router, on router 1, router 2, and router 3. It's very simple as simple. You should be in privilege mode. Okay, and you are saying giving the command like router RIP is very simple, means which enables the RIP protocol. Okay, and you must define the network which that connected locally to that router. Means if you are configuring the RIP on this router, which are the network which are locally connected, that you should define it. That's it. Okay, you should say RIP router RIP, and you can see this changes config router. Then you just define the networks which is locally connected to that router, which is 1.1.0 and 2.0. You can see here in this network, this is 1 dot network and this is 2 dot network. Just I just defined for that RIP, these 2 networks are connected. So what this router will do, it's going to create a packet, and that information is going to share for this. And similarly, if you enable this RIP on this router, defining this one network on this router, it will also send that information to this. Exchanging this information mutually, they would able to get some information which is not new for them. Okay, for those routers. Similarly, if you do on this, exchanging all this information, they would able to even know about the destination. See, the same thing. You just follow this and you just try to ping. How you'll verify it? Ping from one end to another end. So if you get the reply, then you would say, so this successfully you could able to reach the another part. The next one is here. running RIP version 1 with subnet and between the classful network. So the classful network something uh, uh, okay, you just go through it. I've not gone through with this what exactly this experiment is. Okay, so actually the same RIP we are configuring with the subnets and between the classful. So within the classful means here we would be having 172, here 192. So class B and the class C. Okay, and we are planning out something subnetting inside this network. Probably we would be having another separate LAN network over here, and that would comes the subnet of the same network. Probably we're not doing it. You do go through with this description, so you would be able to get to know what you should do it. And the last one is something, a part of the network is going to be enabled with RIP, and a part of that network is going to be static. So where this region we would be calling as stub network, means whatever the request it's going to send to a router, it simply forwarded to one specific path, means this is static. Okay, so it's also very simple. Means up to this you would be doing the RIP, and from this part we would be doing static route. So you just go through it. If you are not able to do it, probably in the next class we can do it. We'll discuss and we'll do it once more time. But you make sure it at least up to this part. So scenario one and scenario should be completed. If you're not able to understand this, probably will in the next class we will discuss up to this from this onwards. Any doubts so far? So I'll upload this to everything on the Google Classroom. You just go through it and submit that within, means in the next week you will be having test, right? After the text, you can submit it. So any doubts? Any doubts? Or any questions from your side? It could be anything. Prabhanjan is there? Prabhanjan? Prabhanjan? Pooja?
Yes, sir.
Any doubts or any questions? Okay, if you are understood, if you are not having any questions, so we'll break for today's session and we'll continue in the next class. Thank you.